Picture a forest in the late Cretaceous. The ground starts to shake as two animals the size of refrigerators sprint straight at each other, heads down, before they collide with a sound that cracks across the valley. This is Pachycephalosaurs. Sitting on top of its skull was a solid dome of bone up to 10 inches thick, housing a brain underneath a wall deeper than the length of your hand. The instant anyone saw that dome, they thought of a battering ram. The shape seemed engineered for high-speed impact, leading to decades of illustrations and stories about dome-headed dinosaurs smashing into each other. But visual resemblance is not scientific proof. Skeptics argued that a thick skull could be a billboard, a heavy, elaborate decoration meant to look impressive without ever actually hitting a target. For years, researchers were forced to guess because they only had isolated pieces. A Pachycephalosaurus was often named from nothing more than a lonely skullcap, a bony bowling ball found tumbling across miles of rock, while the rest of the skeleton fell apart. To figure out if these animals fought, researchers needed to stop staring at the external shape of the domes and start searching for the internal forensic evidence written into the bone itself. When living bone gets cracked or infected, it tries to repair itself. That repair leaves a permanent signature, a mark a paleontologist can read millions of years later. A team of researchers gathered 109 domes from at least 9 different species. They bypassed random damage from fossilization and looked specifically for the pathologies of healed wounds. Out of 109 domes, 22% had pathological lesions. Almost 1 in 4 walked around with healed battle damage. Compared to Triceratops at 14% and Stegosaurus under 10%, dome heads sustained damage far more frequently. Researchers also noticed a pattern in flat-headed skulls, which were likely young individuals or females. The flat skulls lacked these injuries. The scars appeared exclusively on the fully developed, mature domes. If the dome were a random body part, injuries would be scattered across all age groups. The fact that the damage is concentrated specifically on mature individuals strongly indicates these domes were weapons in adult combat. Even with the scars, an alternative theory called flank butting emerged. Instead of charging head-to-head, some researchers suggested the dinosaurs swung their skulls sideways into the soft, muscular ribs of a rival. To test that, researchers mapped exactly where the scars sat. A sideways hit to a soft body would leave fewer marks on the sides. Instead, the wounds clustered right at the apex, the very peak of the skull. That specific clustering at the apex is a pattern we see today. It matches the head-on, high-speed collisions of combat animals like bighorn sheep. To determine if the skull could survive that kind of charge without scrambling the brain underneath, scientists ran a finite element analysis, a digital crash test on a smaller cousin called Stegosaurus. A digital cross-section reveals the skull has a dense outer layer, a dense inner layer, and a less dense middle zone. It functions exactly like a shock absorber, soaking up the blow and channeling force safely around the brain. When compared to living animals, this 3-layer build aligned directly with the duiker, a small, round-domed antelope that engages in extreme head-to-head combat. But a hard helmet is useless if the body behind it collapses. When an animal hits a target at full speed, massive kinetic energy travels directly down the neck and into the spine. The neck curved in an S shape, aligning the head. Interlocking vertebrae lock together, turning the spine into a rigid spear to brace against the shock. From the dense, shock-absorbing apex of the skull, all the way down an interlocking spine, the physical evidence confirms these creatures were engineered to be living battering rams. The evidence for headbutting seemed complete, until a 2025 discovery in Mongolia revealed that the dome appeared much earlier in the animal's life than previously thought. The fossil belongs to Zavacephale. At 108 million years old, it is the oldest definitive dome head ever found, and it is an extraordinarily complete skeleton, preserving delicate parts almost never seen. The standout detail of this specimen is its age. This animal was barely 3 feet long, essentially a teenager. Yet even as a juvenile, it had already grown a fully formed dome on its head. Specialized combat gear used for territorial or mating battles typically develops alongside sexual maturity. Finding a fully formed dome on a juvenile suggests the structure provided a benefit long before the animal reached the age for high-stakes combat. This suggests the early skeptics were partially correct. Because the dome would not have helped against predators or regulated body temperature, researchers argue its primary role for a young animal was social advertising. A visible dome allowed animals to signal health and status to the rest of the group. It acted as a social billboard, potentially allowing individuals to settle disputes through a display of strength rather than physical impact. This dual function mirrors the bighorn sheep. Their curled horns are lethal weapons, but they also serve as flashy status symbols that establish a social hierarchy before any actual fighting begins. These fossils preserve a social world where the dome functioned as a signal and a strike, handling the complexities of status and survival in a single block of bone.